So now let's talk about moments and center of mass. So the moments of mass with respect to the x and y axis are the following two things. So the moment mx, double integral over your region R, y times your density function, and my be the double integral over R. Now it's going to be x rho of xy dA. So those are your two moments, one with respect to the x-axis and one with respect to the y-axis. And then from these you can find the center of mass. The center of mass is the point x bar, y bar, which is, to get x bar, it's my over your mass. And to get y bar, it's mx over your mass. All right, so now that we have these formulas, let's find a center of mass. So let's look at the following example. Find the center of mass of the lamina corresponding to the parabolic region 4 minus x squared, where the density xy at xy is proportional to the distance between xy and the x-axis as shown. So if I'm looking at my region, right, that's described here, I'm looking at the following region. I'll sketch the graph for us. So it's the region right here underneath this parabola, but above the x-axis. And if I have a point here, let's say right here, on x comma y, we're looking, the density is proportional to the distance from this point to the x-axis. Well, that's a vertical distance right there. And what is that vertical distance? That's just y. So your density function is proportional to y, so it's k times y, where k is a constant. And because of symmetry, we know that the center of mass lies on the y-axis. So in particular, I already know that x bar should be 0. So now we need to find y bar. So to do that, the first thing you're going to do is you're going to find the mass, m. So here I describe my region as X goes from -2 to 2. Y goes from 0 to 4 minus x squared. And I'm integrating my density function, which is ky dy dx. So here we get -2 to 2. And this will be k over 2y squared. So I can pull out the k over 2 because that's all a constant. 4 minus x squared squared. So you're going to need to FOIL that out. So m is k over 2, the integral from -2 to 2, 16 minus 8x squared plus x to the 4th. And then integrate that. M equals k over 2, 16x minus 8x cubed over 3 plus x to the 5th over 5 from -2 to 2. So if you plug in your two bounds, you're going to get for m 256 over 15k. So that is one part we need to find y bar. The other part we're going to need is our moment with respect to x, so the x-axis, so you need to find mx. So again, I'm integrating over the same region, -2 to 2, 0 to 4 minus x squared, but now it's going to be y times my density function, which was ky. So now I'm integrating, I'm going to go ahead and pull out the k, y squared. So when I integrate that, I will get y cubed over 3. So I'm going to go ahead and pull out the 3. So then I will get k over 3, 4 minus x squared cubed. Now you are going to need to FOIL this part out. You have 3 copies, and so you're going to have to multiply 2 times. And if you expand that whole thing out, you should be getting 64 minus 48x squared plus 12x to the 4th minus x to the 6th. And then you can integrate after you've multiplied everything out. So you'll get 64x minus 16x cubed plus 12x to the 5th over 5 minus x to the 7th over 7 from -2 to 2. And if you plug in your two bounds here, you'll get for mx 4096k over 105. Now the last thing we need to do to find y bar, it's mx over our mass m, so 4096k over 105 divided by, what did we get for m? It was 256k over 15. So flip up the bottom fraction, and you'll see that the k's cancel. And if you simplify this fraction here, you'll get 16 over 7. So your center of mass, remember that it's x bar, y bar. We said x bar is 0 and y bar is 16 over 7. So in order to find your center of mass, you have to find mass first. You have to find that little m, and then you also need to know your moments, mx or my.